throw an error. And when we click the button, we can see that our error was printed to the console, and that is because basically there is a global error handler that deals with errors in Angular. So we'll look at the first way of dealing with errors, which is the try catch method. Um, the try catch method is used for synchronous operations, so it doesn't deal with async operations like observable calls, also set timeouts. It allows us to gracefully handle errors in the catch block, and with this it helps us improve the robustness and reliability of the code. Um, when you go back to our code, I will add a try catch block to this function. Let me expand this for you. I hope you can see my VS code is visible.
Yeah.
So basically, I've wrapped the function inside a try catch block. And in this try catch block, I'm getting the error. And if the error is an instance of the error object, I am basically setting a variable I have to the error message, and I console this error. When I save and go back to the code and click on the button, basically we can see that this error has been caught by the try catch block. And with this, we can see that try catch block can help us deal with specific errors, and it is mostly used as a specific or a custom way of dealing with a specific error. It can't be used for a wide range of purposes. So the next thing I'm going to show you guys is I'm going to print an error on the browser console. Basically, it's throw error, and the error message is custom. And as you can see, this error message begins with uncaught. So it means this error hasn't been handled anywhere in any aspect of the code. And when we go back to investigate our code, and you remember when this function was outside the try catch block, let me just comment this out. When the error was outside the try catch block and we click the button, basically we don't see that we know for sure that this error was caught by something in the code, since we don't see uncaught here. And this is where we come to the error handler class in Angular. So basically what this means is that Angular has a global mechanism of dealing with errors. And the way to investigate that is on this particular browser browser log, I can view the stack trace of this particular error. And on viewing the stack trace, I can see two functions. I can see one handle error function here and another one below it. When I click on the first one, let me just expand. When I click on the first one, we can see that this error is logged by this function in the class called error handler. So basically, Angular uses this class to globally deal with errors. On further investigation on the second function, we can see that we have a handle error function, which basically um, utilizes an error handler which is fetched from the Angular root injector, basically denoted by this injector.get. And with this, we can clearly see that we can provide our own custom error handler, which will now be injected into our application, which will be bootstrapped into our application during, yeah, um, I wanted to say compilation. Before I continue, I hope you are all with me. If anyone has a question, you can interrupt me before I go on for too long. If there are no questions, I'll continue. So basically what we've learned up to this point is that Angular has a global mechanism, or let's say a global try-catch block that is used to handle errors globally. And with this, this is the function we saw, and the error handler is fetched from the Angular's root injector. And this also denotes that we can inject our own custom error handler in our code. So we go to the custom error handler. The custom error handler is basically a service that will implement the error handler interface. And on the injectable, since we are going to use dependency providers, the provided in root will be removed from the code. So basically, on our console, we'll basically generate a new service. Ng generate service, and you can give it any name you want. And on running this code, it will basically create a new service. And on this new service, it has to implement the error handler class. On further investigation, we can see the default implementation of error handler prints the error message to console, and it is used to intercept error. It is used to intercept error handling, write a custom exception handler that replaces the default one. We have been given an example here where we can define our custom error handler method. And the benefit of using interfaces is when we make an error on the naming of, let's say, this function, it will complain saying that it doesn't correctly implement the error handler interface, because the error handler has to have the handle error method. If we go back to the code, we can see that Angular specifically calls the handle error method. So when we define our custom error handler class, it has to have the same method name as our error handler interface. I hope that is understood. So basically, we will have created a service. The service implements the error handler. I've injected the mat snack bar to show a toaster when an error message occurs. And the error handler basically takes in error argument. We'll put it of type unknown for now to ensure that I think it's more type safe than any. And basically what I want to do is open a snack bar with the error, and the duration is for 2 seconds, and I also log it to the console. Now when we have created this class of ours, we'll have to go to the app module, and on the app module in the providers, we'll basically add the error handler provider, and the class we are using is a custom error service, which is this one. So when I save this, basically what I've done is I've implemented my own custom error handler. So basically on this widget, instead of the default way that Angular deals with this error, Angular will inject my custom error handler into the application, and that is what will be used to handle errors. So let's have a look. When I'm back to my browser and I click on the button, basically we can see a error message, customly caught the error, and that is what we have here, customly caught. You also see the snack bar is appearing at the bottom, which means that we've successfully implemented the custom error. Benefits of this is basically you'll have a centralized place of dealing with all your errors, and you won't have to fill your code with custom ways of dealing with specific errors. You'll have a lot of try catch method. You use this old method. um, Another thing I would like to talk about is, oh, okay, before I continue, I hope that was understood on how to implement the custom error handler. Basically, we just create a service, and in the app module, we inject it in the providers. And yeah, so another thing I would like to talk about is what we said about okay, let me talk about propagating the errors downstream. Initially, we saw that our try catch block was basically setting our variable with the error, and the error message was able to be printed here at the top. In our situation, let's say we want that error message to reach the component. So basically in this custom error, we'll have to rethrow the error back downstream. And with that, we use the throw method. And I say throw error, and in my try catch block, I'll basically uncomment this, put it here. Now what we can see is the custom error service is basically catching our error. Oh, this is wrong. Okay. Basically what we are doing here, the try catch is the first point of contact with the error. And when this error is caught by the try catch, we can see that it has been printed here. And the only way to propagate this error to the global error handler is by using the throw error method. And by using throw error, basically what we are doing is transferring this error globally. And it now comes to the custom error service and is now printed on the snack bar. If we look at it here, basically it prints the error on the component. The component logs the error. It is then transferred to the custom error handler, which now prints the snack bar. So that is how you propagate the error downstream or upstream. The last thing I want to talk about on this section is the micro and macro tasks. So try-catch blocks don't deal with async operations or things like set timeout. When we go back to our code and basically put our widget in a set timeout, we can see that our try-catch block has not printed anything. This error goes directly to the custom error handler. And we can also see that our snack bar is wrongly positioned and all that. So to do some further investigation as to why this is happening, we can view the stack trace of this particular error. And the first thing we see is the handle error method, which we can see is called by the custom error service that we defined. But what I want to look at is the second function that is being called. And on the second function, we can see some interesting things. I won't explain this in detail because I probably have mixed information. But basically what we are talking about here is how Angular bootstraps our whole application. And in all this bootstrapping, there is something called the zone or the ng zone or the zone.js. And I've provided some short descriptions on what the three are. The zone.js is the library that provides that whole environment for zone execution context. The ng zone is the service that provided by Angular that utilizes the zone.js library for change detection. And the zone is now the actual execution context that is basically used to deal with async operations. When we go back to investigating this code, basically we see that after doing some initial things, the ng zone is run, and inside it, it basically defines an exception handler. This exception handler takes an instance of the error handler, and in our case is the custom error handler that we define. And when a macro operation is completed, this particular subscription will now run. But as you can see, it is running outside the Angular zone. And it's been printed by this exception handler.handle error. But that basically explains why our toast comes in the top left corner instead of the bottom. Now to deal with this particular change, basically we'll just inject the zone into our custom error component and ensure that this snack bar is executed when the zone inside the zone or when the zone is running. So when you go back to our browser and execute this particular function, you can see that the toaster now appears in the correct place. Um, and on that, I think for the first bit of custom error handling, um, I hope it was short and brief. Um, Allow me to continue slightly to RxJS observables and how to handle the errors. The first part was dealing with mostly normal normal errors, but we've all faced the situation where we are making API calls and we also want to deal with these errors gracefully. So the common operator that is used in RxJS for catching errors is the catch error operator that is used inside the pipe. This operator handles errors that might occur during the execution of the observable stream, and it allows us to gracefully handle errors and continue the observable stream with a fallback or alternate behavior. So in my component, basically what I have is, let me first, basically what I have is an observable. I've defined an observable here, and this observable basically is obtained from the load method that we defined in the widget service. And basically in the widget service, what it's doing is fetching to-dos from the JSON placeholder. And in my pipe operator, I have commented out the catch. So what I'll do for now is make sure the endpoint returns an error. And as you can see, when I changed the URL, added an invalid character, you can see that our global error handler caught this exception. And on further investigation, we can see that it was what we are talking about, the micro and macro tasks. Since RxJS API calls are an asynchronous operation, they fall under micro tasks. So they'll be run outside Angular, and when that error occurs, it will be handled by this function here. Now, what we want to do is use the catch error operator to deal with this particular error. So I'll come and comment this out. So basically what we have here is the catch error operator that takes in a function as an argument. And in that function, I basically log an error that says widget service. And let me change this to an error. And I set a catch error operator can return an observable, must return an observable as we see here. And on returning this observable, what I say is when this API returns an error, set the list to an empty array. When I save this function and go back to the browser, we can see what is only printed is the widget service error caught when making API call, which is this one here. No other error is printed downstream. So you might be wondering, what if we want to handle the error in the component. What if you want to print that error message here at the top? So what we do with that is the same as the propagation of the error in the custom error handler. So in our widget service, we can basically rethrow this particular error by using the throw error function. And this throw error function basically takes in another function as an argument. We can log that the widget service rethrew this error, and we can return a new error. Let's say could not load data from service. So basically what we are doing here is this API will first catch this error. It will take this error and propagate it downstream to the component that is calling this particular function. And in our situation, it's the widget component. And on the widget component, basically what we do is we'll uncomment out this catch error part. So basically what will happen, this error will now be caught by the widget component. The variable will be initialized by that error. Let me comment this out. So now what we can see is the widget service caught the error first and printed this message. Widget service, let me reduce this a bit. Yeah, the widget service error caught when making API call. It is then rethrown to the next downstream component, which is the widget component here. And then it is caught by the widget component. The widget component prints that error. It initializes the variable to the error that we retrieve. And finally, it rethrows that same error to the global error handler, which now prints this customly caught the error. This is one way of dealing with errors in RxJS observables, but in order for us to deal with them globally, we can use a HTTP interceptor. So basically on the command line, we can generate an interceptor, call it HTTP interceptor. And basically when I run this command, it will create a class called HTTP, whatever name you had given it, and it implements the HTTP interface class. And on this particular interceptor, we can carry out a number of things. First of all is this particular interceptor returns the HTTP handler, and the .handle method returns an observable of which we can call the pipe method. And on the pipe method, we can do some particular things. One of the things we can do is define the number of retries. So let's say we want to retry 3 times before we throw an error. We can define a retry. The other thing we can do is define our own catch error that will be caught at first level. So basically what we are doing here is login. After we've defined a HTTP interceptor, we'll head over to the app module file and inject it in the providers. So it's provide HTTP interceptors. We use our custom class called HTTP class interceptors, and we set multi to true. And on saving this particular code, we can see first of all our API is being called 3 times before an error is thrown. Then the HTTP interceptor catches that error. After the HTTP interceptor has caught that particular error, we can see that we've rethrown it downstream. So basically the next component that is going to catch this error is the widget service component, and the widget service component will catch this error here, propagate it again downstream to the widget component, and the widget component will now take this error, assign it to a variable, and then propagate it downstream to the global error handler. Um, I think with that, we have covered on the retries. The other things you can perform on a HTTP interceptor is alter the headers. We can also perform a token refresh. And without further ado, I think that is it for the custom error handling presentation. We've learned about the 5 P's of error handling. Proper prior preparation prevents poor performance. And I think now the floor is open to anybody who has burning questions or a clarification on what I have talked about.
Wow, that was amazing. Thank you very much, Karanja. Informative session. I think speak for most of the developers here in the sense that we are used to some of the most basic error handling mechanisms. Done, we read some article somewhere or someone has taught us how to do it. But I think personally, I haven't really gone in depth into like, dismantling the bits and pieces of where exactly can you, handle those errors or catch those errors as early as possible. So thank you very much for giving us this glimpse of custom error handling. I'd like to open the floor to any questions or any comments or suggestions that you may have. Please feel free to, you could probably raise your hand and just call you stage. Feel free to ask any question. We are all here to learn, so don't feel shy of asking any question. My motto is usually no question is stupid. Everyone is unique and everyone is always looking to supplement their knowledge. So it's always good to ask any question that you have. Any question? Okay, as we move for someone else to ask. So Karanja, maybe this is a question that maybe someone might have. But sometimes we might have, different errors coming from the back end, and let's say for some reason, maybe the backend that provided the API endpoint haven't provided proper error messaging for you to be able to handle something happens in case there's a problem. Like, how do you go about handling such kind of cases in the front end?
Okay, to reiterate your question, basically what you're saying is if the backend The backend error messages are different, or I didn't quite get that question.
Yeah. So, for example, let's say the backend team has, of course, has given you the endpoints, but then when it comes to handling error scenarios, they haven't really provided you with proper error messaging. So, how do you go about it?
What I can say is the HTTP error, HTTP interceptor will come in really handy, because that is the first point where the the API errors will be caught, and at that particular level, probably you can put some conditions to check on the status codes, or yeah, I think that's the only way I can handle it.
Right. And just as a heads up, I mean, also just something to add on to that. It's always important also for us as front-end engineers or front-end developers to always look at what we usually call the three paths, right? The success path or the happy path, the error path, and also the loading state. So having to be able to provide that proper um, visualization of what exactly is happening at a particular point in time is very, very important to the user so that they can get to know what is happening. If something is loading, let them be know that something is loading. If there's an error, also be able to have a way of handling that error. I think that is something that's very, very important in our in our line of work, especially when it comes to front end engineering. Because I think you've this maybe somewhere is that being a front end developer is not just about um, making things look nice, the UI and all that, but then it's also trying to be a conduit between the backend and the user. So, for example, you're getting this error coming from the backend. You understand it as a front-end engineer or front-end developer, but then the user doesn't. So, how can you make sure that even if there's that error message coming from the backend that is a bit too technical jargony, right? How can you simplify it in the UI? So that is where catching those errors comes in handy, whereby you're able to edit it or modify it before it's shown into the UI. Yeah. Any question, maybe, or a comment or a suggestion you might have?
Um, Wayne, I had a question probably to everybody and anybody who can chip in.
Uh,
Um, we've all dealt with the JWT tokens and also the refresh token. But I was having a discussion with a developer, and how do we, or where is the best place to actually carry out that refreshing of the token? Is it in the interceptor, or where do you handle it? If anybody can chip into that question. Or how do you guys refresh tokens in Angular?
yeah. Anyone, please feel free to answer. Again, as I mentioned, everyone has a unique way of doing things. So feel free to provide also your insights on how you do it and why you do it.
Hi everyone. Aranta, do you mind repeating the question?
Hello, Winnie. My question was, how how do you guys deal with refreshing the JWT token? Let's say the token is set for, let's say, 5 minutes. Those 5 minutes elapse, the user is still browsing your website, but when they click on another link, What I usually do is I log them out and require them to log in again. But there's this concept of using the refresh token. So how do you guys implement that in the background without having to log out and log in the user again?
Okay, so without logging, without relogging the user again, I think from the projects have taken part, what we mainly do is from the GWT library, there's a function called is token expired. Yeah. So basically I think what I'll do is I'll just take the token and pass it through that function. If it has expired, I'll request for a new token. If not, I'll just let the user continue using it. That's one way I have handled it. Though I'm not sure if it's senior engineerish. Yeah.
Um, um, do you do this at the service? Let's say the HTTP service, the interceptor.
No,
The discussion was it's better to put it in the interceptor than anywhere else.
the one I've done, we did it on the card.
Oh, the auth guard. Mm, mm.
Yeah.
I think somebody has raised their hand. Dedan, I think you can ask away or answer away.
Thank you. Thank you, Karanja. So the way I would approach it is use the interceptor, where I would check for each request that it's incoming, check for the status code, whether it's 4.1. So whenever we have a 4.1, we'll trigger that JWT does usually have those helpers. So we'll leverage that helper called is token expired. So from there, if for instance we get a 4.1 in status code, then we'll trigger calling that is token expired. So we leverage both the interceptor and the global service, where the interceptor will check for the status code, then it will call the is token expired from probably a global service like an auth guard. Then from there, trigger a refresh token, and then from there, it will prompt the user to proceed with the session.
Okay, I think that's well understood. Isaac, I think you can continue.
Uh, yeah, just on that question, I was just struggling to with this question. For example, on the refresh token piece, for instance, we say I was browsing and I forgot to log out whatever I was working on, and let's say 2 hours later, another person, not necessarily me, comes and continue from where I left. Maybe I forgot to lock my machine or something of the sort. So uh, that will mean if they continue from what my colleague has just mentioned, they'll maybe if it is something that was confidential, they'll continue interacting with the platform. So I don't know. My question is, what is the normal way, or the usually what the conventional way is that when the token expires, the user is logged out and then they're prompted to log in. So I don't know whether that may pose a challenge in terms of security wise or data or confidentiality. If I don't, maybe someone can help me on how we to handle that.
Hapo pia umeniweza mimi.
Hello, maybe I can contribute there. So we do have the lockout screen timeout. So for example, you've specified that if the portal is idle for for around 5 to 10 minutes, then log out or just log out the user and then lock the screen. But then for the session, for the token, we are talking about the session. So for these, we normally have the JWT token that's coming from the backend, and it usually has a time set until when it expires next. So this expiry will happen. This checking will happen when you're using the portal. So once it expires, even if you had probably left the machine, or you had left the portal and you had not logged out. So once you log in again and the session had been set to expire in the next 1 hour, you'll be prompted to log in again. But for the instance of you being idle within that portal even for the next 10 minutes, then you'll be logged out and then you'll be logged in again. You'll be logged out, yes, but you're required to be logged in again. So that I don't confuse you, for the session, for the refresh token that you're talking about, this refresh token happens instantly when you're still using the portal. So if your token has expired, you'll be prompted with a pop-up that says your session has expired. Do you wish to continue? Do you wish to proceed? So if you click yes, then the refresh token happens and you just proceed with the session. But if you say no, that's the time that you'll be logged out automatically, and then you'll be prompted now to logging again with your credentials.
Yeah, thank you for that. I think I'll try something around that. Yeah, I think that was a good answer. I can try that.
Cool.
Any-
But
anyone?
maybe you can get another suggestion.
Thank you, Dedan. I don't have any other suggestion. I think that was well explained by you.
Okay, thank you. Thank you all. Thank you for the contributions, by the way. That's a very interesting question. I'm actually learning something as well while at this. Anyone else maybe who has another question? A question or a comment or a suggestion? I will also share with you all an article that touches on most of the things that have been discussed over here with regards to the questions on the JWT tokens. I've seen people can have different ways of how they handle their refresh tokens. Some usually do it on the interceptor level. So that particular article talks about how you can handle it on the interceptor level. And so I think it might be interesting for you to check it out and probably read it and then see if it's something that maybe for the one who had asked the question can really help you. Anyone else maybe who has a question? Question? Okay, check that as a no. All right. I'd like to say once again a big thank you to each and every one of you who enjoyed the session. It was great to have you all.